hard enough and the compressor gets to 900 centigrade, the protective titanium oxide on the surface diffuses in, and I have titanium exposed to 30 atmosphere oxygen, or 30 atmosphere air, which is, what's the oxygen pressure in 30 atmosphere air? 20% of 30 is 6 atmospheres. So 6 atmospheres of oxygen is pretty aggressive in terms of a fire, and just it's like a flare going off inside your engine. It's just your compressor burns up into nothing. Not a good day. So a lot of these principles, hopefully you'll start to see how a lot of these things fit together. Okay, it's the same physics. It's just kind of, I tie it together with welding because that's what got me tenure. Okay. Other questions? Or actually, you haven't asked any questions yet. What questions do you have? Yeah.
In one of your lectures at the end, you talk about how graphite in outer space isn't a lubricant anymore.
Right.
Then the next lecture, you didn't talk about it again, so I don't know if that comes later or if not. Maybe.
Oh, if I didn't talk about it again, well, here's the book. Cold weld adhesion or cold welding of materials in space environments. Okay. This is a symposium held in 1967 in Toronto, Canada. American Society for Testing of Materials and American Society for Lubrication Engineers. Not that it's really important, but what happened in the first mercury shots, everybody knew graphite was a lubricant. So they had shafts, little and whatnot in the mercury capsule and the module and whatnot. And everybody figured, well, this is fine. It works as a lubricant on Earth. And so they found that when you got up in space, it became an adhesive. It bound things together. And the reason is that, and I actually could have brought a crystal structure model. Graphite is hexagonal close packed. So it's like a bunch of honeycombs of a beehive, okay, in terms of hexagonal close packed, hexagons layered together, okay, stacked together and layered together. So you have basal planes that can slide easily and shear, and everybody figured that was just inherent in the properties of the hexagonal close packed crystal structure of graphite. Well, it's not. It turns out carbon-carbon bonds are some of the strongest bonds in the universe, and it turns out the only reason graphite slides on its basal planes is there's a layer of oxygen in between. That's your surface contamination. And if you go up into space, a rarefied environment, the oxygen diffuses away, and now I have carbon-carbon bonds. So what's a lubricant at atmospheric pressure becomes an adhesive at low pressure. And in fact, I had a student who was actually 13A student, but 2N type of student years ago. What was his name? Dan Reese, okay? And I remember Dan was working on gas metal arc welding of titanium because the Navy was interested in titanium submarines. And so we had a glove box over here, and he was doing gas metal arc welding, which is a fine wire of titanium being fed into a weld pool with an argon arc. And we had an atmosphere that was in the glove box that we had cleaned up. We were using liquid argon, so it was ultra pure. And then we had a titanium getter that we could run all night and get rid of all the oxygen and nitrogen contamination in there. And we were down at like 10 to the minus 13 atmospheres of oxygen on a little sensor that we had. And Dan, inside the glove box to clean up the weld fume and spatter, had a little hand vac, and it turns out they lasted for about 2 hours because the graphite brushes would wear out. I mean, they worked fine in the air, but inside 10 to the minus 13 atmospheres of oxygen, the graphite brushes, it worked and it carried the current to the motor, but it abraded away really quickly, relatively quickly. So we bought lots of hand vacs because that was the solution. But the solution that NASA had eventually, there are other materials that are lubricants that have the same hexagonal close packed graphite structure as graphite. Things like molybdenum disulfide. Okay, molybdenum disulfide is another lubricant, but in that case, the structure has the sulfur which creates the low energy surface for the basal planes, and it's not pulled away when you go to a vacuum. Okay, molybdenum disulfide is actually a very, very stable sulfide. It melts at like 2200 centigrade, and so no vacuum is going to cause it to separate. So all you have to do is go to molybdenum disulfide. But because of this problem on some of the early mercury shots, everybody know what mercury was? Mercury was before the ones that, what do we call? Apollo was later. There's Mercury, Gemini, and then Apollo, I think. Mercury was Alan Shepard going up to outer space above 100 miles and coming back down, but not going around the world. Gemini, I think, was John Glenn taking a trip around the world. And then Apollo was President Kennedy saying, we're going to go to the moon. Okay, so there were several stages. I lived through it. I lived in Virginia Beach, and the Civic Center in Virginia Beach is named the Allen B. Shepard Civic Center because he was a commander in the Navy in Virginia Beach at the time he went into space. Okay. Not that he was from Virginia Beach, but he lived there at the time. Anyway, and there's not a lot of famous things coming out of Virginia Beach. Okay. Actually, he wasn't my classmate. I think there was Commander Jeremiah Denton. Anybody ever heard of Commander Denton? His Navy commander, pilot in Vietnam. Anyway, he was a prisoner of war, and they put him all over the front page of the news, or the North Vietnamese put him all over the front page of the newspaper. His family just lived down the street from us, and he was sort of a hero because he was being tortured, but he wouldn't give any information other than name, rank, and serial number. But anyway, they kind of turned him into a hero. And it was a good family. I mean, so far as that goes, I'm not trying to disparage him, his hero status. I wouldn't want to be a prisoner of war for 5 or 6 years in North Vietnam. Okay, any questions? Yeah.
Follow up on his question on shear.
Yeah.
One of the reasons why they stacked the plies for the carbon fiber reinforced polymer at 45 degrees to prevent the shear force from pulling the laminates apart.
Yeah. I mean, you've got these graphite fibers that are oriented in the strong direction, and they don't have such good properties in other directions. So then that's. Did I send this around before? This is a piece of the X-33 space plane liquid hydrogen tank, and it's actually got carbon. It's a Nomex honeycomb, which is basically like Kevlar. They make fire suits out of Nomex. Okay, it's just a fire-resistant fabric. And the outside of this is different plies at 45, 0, 45, and 90 of graphite fiber sheets that are glued together. And they had an adhesive failure. It's one of the reasons I brought it. We can talk about that. But are we having class tomorrow, the next day? Okay. And people are presenting those days? How many people each day?
You said to budget, I don't know, you said we probably get through 2 a day. So
Yeah.
I know that we have people lined up, so I guess if we can get through more than 2 a day, I'd sort of push. But
We might be able to do 3 a day if I don't speak. But if we got 2 people set up today, why don't we take one of those people? I've got my laptop. If you got a laptop, who's speaking today? You ready? You want to go? You got your laptop?
Yes, sir.
Here's an HDMI cable.
Thank you.
Okay. Anybody got a piece of paper I can borrow? Just a single piece, yeah. I got to write. Oops. No, I need to get a pen. I'll go get a pen while you're setting up. Sorry. And paper. Okay. We don't have to videotape your presentation so far as that goes. Would you like them videotaped?
No, thank you.
Okay. It's actually good practice.